Going to expand 3x minus 2 to the fifth power using Pascal's triangle. So since we're taking this to the fifth power, you want to look to row 5 on Pascal's triangle and space out those coefficients. So those coefficients are 1, 5, 10, 10, 5, and 1. Space those out across your paper. Leave enough space after them so that you can put the 3x in and also the negative 2 in. After you get those coefficients spaced out, then you're going to put the 3x in. Start 3x off to that fifth power. So take 3x to the fifth and work your way down to 3x to the 0. So it'd be 3x to the fourth, 3x to the third, 3x squared, 3x to the first, and finally on the end, 3x to the 0. Then you start the negative 2 off in the opposite direction. Start negative 2 off to the 0 power and work your way up to negative 2 to the fifth. So it'd be negative 2 to the first, negative 2 squared, negative 2 to the third, negative 2 to the fourth, and on the end, negative 2 to the fifth. All you have to do now is simplify this. In this first term, take 3 to the fifth, that is 243. So that'd be 243x to the fifth. You don't need the 1. And negative 2 to the 0, that's just 1. You don't need that as well. Next term, 3x to the fourth. If you take 3 to the fourth, that is 81. So that would be 81x to the fourth. You have a 5 out front. Negative 2 to the first power would just be negative 2. Next up, 3x to the third. Take 3 to the third, that is 27. So that'd be 27x to the third. Have a 10 out in front. And then negative 2 squared. Be careful on that one. If you type that in your calculator, you want to put parentheses around the negative 2. Because if you type in negative 2 squared on your calculator, it reads it as the negative of 2 squared, which would be negative 4. When you take a negative number to an even exponent, that's going to be positive. So that is positive 4. On your calculator, put parentheses around the negative 2, square it, and you will have positive 4. Next up, take 3 to the second, that is 9. So that'd be 9x squared. Still have that 10 out in front. On the end there, negative 2 to the third. When you take a negative number to an odd exponent, that is going to be negative. So that would be negative 8. Next, take 3x to the first. That's just 3x. Have a 5 out in front. And then on the end, negative 2 to the fourth. When you take a negative number to an even exponent, that is positive. So that would be positive 16. Finally, 1, we don't need that. 3x to the 0, we don't need that. That's just 1. And if you take negative 2 to the fifth power, take a negative number to an odd exponent, that is negative 32. Keep simplifying this. You have 5 times 81 times negative 2. That would be negative 810x to the fourth. Next, 10 times 27 times 4. That is 1080x to the third. Next, 10 times 9 times negative 8. That is negative 720x squared. 5 times 3 times 16. That would be 240x. And finally on the end, negative 32. So final answer here, 243x to the fifth minus 810x to the fourth plus 1080x to the third. Minus 720x squared plus 240x minus 32. That is the expansion of 3x minus 2 to the fifth power. We're going to expand 2x minus 2y to the sixth power using Pascal's triangle. Since we're going to the sixth power, we want to look to row 6 of Pascal's triangle and pick out those coefficients. So those coefficients of 1, 6, 15, 20, 15, 6, and 1. You want to space those out across your paper, leaving enough room after those to put the 2x in and the negative 2y in. So space out those coefficients of row 6, and then we're going to put the 2x in next. So start with that 2x to the 6th power. Then you're going to work your way down to 2x to the 0 power. So it'd be 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, and finally on the end, 2x to the 0 power. Then you start the negative 2y off in the opposite direction. Start negative 2y off to the 0 power and work your way up to negative 2y to the 6th. So it'd be negative 2y to the 1st, negative 2y squared, negative 2y to the 3rd, negative 2y to the 4th, negative 2y to the 5th, and finally on the end, negative 2y to the 6th. Quick check your exponents. Make sure each pair of exponents adds up to that main exponent of 6. All you have to do now is simplify this. Take 2 to the 6th power, that is 64. So it'd be 64x to the 6th. We don't need negative 2y to the 0, that's just 1. We don't need that 1 out in front. 64x to the 6th is fine there. Next, take 2 to the 5th, that is 32. Don't forget you have that 6 out in front, so it'd be 6 times 32x to the 5th. Negative 2y to the 1st, that is just negative 2y. Next, take 2 to the 4th, that is 16. So it'd be 16x to the 4th with a 15 in front of that. Take negative 2 to the 2nd, that is positive 4, so it'd be positive 4y squared. Next, take 2 to the 3rd, that is 8. So it'd be 8x to the 3rd. Don't forget the 20 in front. Negative 2 to the 3rd is negative 8, so it'd be negative 8y to the 3rd. Next up, take 2x to the 2nd, that is 4x squared with the 15 in front. Negative 2 to the 4th is positive 16, so it'd be positive 16y to the 4th. 2x to the 1st is just 2x with the 6 in front of that. Negative 2 to the 5th is negative 32y to the 5th. And then 1, we don't need that. 2x to the 0, we don't need that. That's just 1. Take negative 2 to the 6th, that is positive 64. So it'd be positive 64 y to the 6th on the end. Still have some multiplying to do. Take 6 times 32 times negative 2, that would be negative 384. 15 times 16 times 4 is 960. 20 times 8 times negative 8, that'd be negative 1280. 15 times 4 times 16, that is 960. 6 times 2 times negative 32, that is negative 384. And on the end, we don't need to do anything there. Thank goodness, 64. So the final product, when you expand 2x minus 2y to the 6th power, you get 64x to the 6th minus 384x to the 5th y plus 960x to the 4th y squared minus 1280x to the 3rd y to the 3rd plus 960x squared y to the 4th minus 384x y to the 5th plus 64y to the 6th. One quick check your exponents. Make sure each pair of exponents adds up to that main exponent of 6. But that is the expansion of 2x minus 2y to the 6th power. We're going to take x squared minus y squared to the 3rd power using Pascal's triangle. So go to row 3 of Pascal's triangle, since we're going to the 3rd power, and pick out the coefficients of 1, 3, 3, and 1. On your paper, you're going to space out those coefficients. Coefficients are 1, 3, 3, and 1. Leave enough space after those coefficients so that you can put the x squared in and the negative y squared in. So start the x squared off to that 3rd power and work your way down to x squared to the 0. So it'll be x squared to the 3rd, x squared to the 2nd, x squared to the 1st, and finally x squared to the 0. Start the negative y squared off in the opposite direction. Start negative y squared off to the 0 power and work your way up to negative y squared to the 3rd. So it'll be negative y squared to the 0, negative y squared to the 1st, negative y squared to the 2nd, and finally on the end, negative y squared to the 3rd. Then just simplify this. X squared to the 3rd power. When you take a power to a power, you multiply the exponents. It'd be x to the 6th. Don't need the 1. We don't need negative y squared to the 0. That's just 1. So x to the 6th for the first term. Next term, x squared to the 2nd power would be x to the 4th. Negative y squared to the 1st, that would be negative y squared. Don't forget you have a 3 in front of that. Next, x squared to the 1st, that is x squared. Then you have negative y squared to the 2nd power. When you take a negative term to an even exponent, that is going to be positive. So that is positive y to the 4th. Next, we have a 1. Whether you write that or not in the next series here, it's up to you. We're not going to need that in the end. Negative y squared to the 3rd. When you take a negative term to an odd exponent, it's going to be negative. So that is negative y to the 6th. Keep simplifying this. You have 3 times x to the 4th times negative y squared. That'd be negative 3x to the 4th y squared. 3 times x squared times y to the 4th is 3x squared y to the 4th. And on the end, the negative of y to the 6th. So final product here, when you expand x squared minus y squared to the 3rd power, you do get this. X to the 6th minus 3x to the 4th y squared plus 3x squared y to the 4th minus y to the 6th. Going to expand a minus b squared to the 5th power using Pascal's triangle. So since we're going to the 5th power, you want to look to row 5 of Pascal's triangle and pick out the coefficients of 1, 5, 10, 10, 5, and 1. So space those coefficients out across your paper. Coefficients of 1, 5, 10, 10, 5, and 1. Space those out with enough room after those so that you can put in the a and the negative b squared because that's what's next. I'm going to start the a off to the 5th power and work your way down to a to the 0. So it'll be a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and finally a to the 0. Then start negative b squared off in the opposite direction. Start negative b squared off to the 0 power and work your way up to negative b squared to the 5th. So it'll be negative b squared to the 1st, negative b squared to the 2nd, negative b squared to the 3rd, negative b squared to the 4th, and finally negative b squared to the 5th. All you have to do is simplify this. Out front, we don't need the 1. We don't need negative b squared to the 0. That's just 1. So that first term will be a to the 5th. And we have 5 times a to the 4th times negative b squared to the 1st. And that negative b squared to the 1st, that is going to be negative b squared. And we have 10a to the 3rd times negative b squared to the 2nd. When you take a negative term to an even exponent, that is going to be positive. So that is positive b to the 4th, multiplied by that 10a to the 3rd. Next, negative b squared to the 3rd. When you take a negative term to an odd exponent, it's going to be negative. So that is negative b to the 6th. We still have a 10 in front of that with the a squared. Next, negative b squared to the 4th. Again, when you take a negative term to an even exponent, that is going to be positive. So that's positive b to the 8th. When you take a power to a power, multiply the exponents. So you have 5a b to the 8th for that term. And finally, 1, we don't need that. A to the 0, we don't need that. If you write a 1, that's fine. We just don't need it in the final product. Negative b squared to the 5th. When you take a negative term to an odd exponent, that is going to be negative b to the 10th. Still clean this up. We have 5 times a to the 4th times negative b squared. It would be negative 5 a to the 4th b squared. 10 a to the 3rd b to the 4th. Nothing changes there. 10 times a squared times negative b to the 6th, that would be negative 10a squared b to the 6th. 5ab to the 8th, nothing changes there. And finally on the end, that is going to be negative b to the 10th. So that is the final product. That is the expansion of a minus b squared to the 5th power. You need to find the 4th term of the binomial expansion of x plus 2 to the 5th power. So since we're going to the 5th power, we want to look to row 5 of Pascal's triangle and pick out the 4th coefficient because we're looking for the 4th term. So row 5, count over 4 coefficients. The coefficient is going to be 10. So the coefficient is going to be 10. And then think about your x. You're going to start the x off to the 5th power and work your way down to x to the 0. So it'll be x to the 5th, x to the 4th, x to the 3rd, x squared. So now we have a 10 and an x squared. Then think about the 2. You're looking for the 4th term with that 2. So start the 2 off to the 0 power and work your way up to 2 to the 5th. So it'll be 2 to the 0, 2 to the 1st, 2 to the 2nd, and right there is where we're stopping, 2 to the 3rd. That is the 4th term. So what we have right now, we have a coefficient of 10. We have x being taken to the 2nd power because we went x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. And then we have a 2 to the 3rd because we started 2 off to the 0, to the 1st, to the 2nd, and 2 to the 3rd. So we have 10x squared times 2 to the 3rd. That'd be 10x squared times 8 because 2 to the 3rd is 8. And that would be 80x squared. So the 4th term of the binomial expansion of x plus 2 to the 5th is this 80x squared. You need to find the 5th term of the binomial expansion of a plus 5b squared to the 4th power. So since we're going to the 4th power, we want to look to row 4 of Pascal's triangle and pick out the 5th term. Well, the 5th term would be that last term, that last coefficient. So the coefficient we want on this is 1. And then start the a off to the 4th power and work your way down to a to the 0. So that last term is going to be a to the 0. So 1, we have a 1 right now as a coefficient, and then a to the 0. Then 5b squared, that will start off at 5b squared to the 0 power and work its way up to 5b squared to the 4th. So what we have right now is a coefficient of 1. We have a to the 0 and 5b squared to that 4th power. Just simplify that. 1, we don't need that. A to the 0, that's just 1. We don't need that. Just take 5b squared to the 4th power. Well, 5 to the 4th is 625. B squared to the 4th is b to the 8th. 625 b to the 8th, that is the 5th term of the binomial expansion of a plus 5b squared to the 4th power.